In this chapter, we're going to be learning all about server routes in Nuxt 3. We're going to refactor the app to, instead of serving our course data from a JSON file or a JavaScript file, instead we're going to be fetching that data from the endpoints. And then once we've done that, we'll then set up our database using Supabase and Prisma, and then we'll be able to put that data in our database and fetch it from there. And as we go through all of this, we'll start to learn about how routes work. We'll learn about useasync data and all the different ways that we can fetch data in Nuxt. We'll also learn Prisma and how to use that to fully type our database endpoints. And then at the end, we'll learn a lot more about Nitro and how Nitro powers so much of the magic and the amazing features that Nuxt gives us. In this lesson, we'll be taking a look at how server routes in Nuxt 3 work. We're also going to use a tool called Hopscotch to help us develop these routes. If you've ever worked on a server API, it can be really annoying to constantly need to go into our page and manufacture these fetch requests in order to test that the server is doing what it should. So there are tools like Postman and Hopscotch, which allow us to more easily test these endpoints. So in this course, we're going to be using this tool called Hopscotch. Hopscotch.io is where you can find it. And it runs in your browser, but lets you still make requests to your local host, which is really cool. It's also built using Nuxt, which I think works perfectly for this course. A fun fact for you is that Hopscotch used to be called Postwoman. And in the very first course that I created, Clean Components, I actually did a series of screencasts where we went into Postwoman and looked at the source code and did some interesting things there. So for me, this also makes a lot of sense to use this, and it's a great tool. So before we actually are able to use the tool Hopscotch, we first need to create our endpoint. So we'll do that using Nuxi. If we come over to our terminal, we'll type in Nuxi add API world. And you'll see that this was created in the server/API directory. And if we open this up, we can see that we use the define event handler method. And then inside of that, all that we're doing is creating this function that returns a string. So pretty straightforward. To see how this request works, we're going to create a collection in Hopscotch to organize all of these different requests that we're going to be making. So naturally, we will call it Mastering Nuxt 3. And then inside of there, we will do Hello World. And now you can see that we've got this request inside of Mastering Nuxt 3 folder. This green dot shows that we're active on the request. So that's a bit of a confusing part, or it confused me at least, with this UI, is that you need to make sure that this green dot is on. If you click on it a second time, then now we're not in any specific request. And the changes that you do will be for any new request you want to make. So make sure that you've clicked on this, and that it's showing that green dot. And then we can type in HTTP localhost 3000. And then our API lives at /API/world, the name of the file. So I hit send, and we can see that the response is hello world, exactly what we wanted. So I'll add an exclamation mark there. If we send it again, you can see that that updates in there. Okay, so that's the very most basic way of creating a server endpoint. All right, so now we've created the most basic endpoint that we could possibly imagine. One thing to know about the server is that all of these live in the /API directory. But this is actually a shorthand. It's equivalent to if we had the server/routes/API. So if I move that over, you can see that we're now server/routes/API. And if I send this request, we get the same thing back. So this lets us put any routes that we want in this server/routes folder. If we don't want this API prefix, we can move this into the top folder here, into routes. And then if we remove that from here, we get the same request back. And so you can see that the routing system here is actually the same as what we were using in our pages directory. And in fact, it's the exact same thing. We can even put in route parameters and optional segments the same way that we would with our page routing. But it's a good convention to keep our API routes prefixed with this API here. So we're going to move that back. And we'll use this shorthand instead, just because it's a little bit nicer and easier to work with. So now we need to create our actual API endpoints. So let's think through this for a moment. The data that we need to access in our course is the data for the current lesson that we're on. And so maybe we could create an endpoint for that, a lesson endpoint that matches the same endpoint or route that the pages are using. And the second thing that we need is some metadata about the course so that we can get a list of all of the lessons so that we can render the navigation on the left-hand side, as well as the name of the course, since we're using that on every single page. So we'll be able to create two different endpoints, a lesson endpoint and then a metadata endpoint. So we're going to jump into creating that lesson endpoint first. What we're going to do is create a matching route that will match this route that we have up here. So we'll do that in our API here. We'll do course/chapter/chapter slug/lesson/lesson slug.ts. And we'll want to use this define event handler in there. So now let's go over to Hopscotch and create a new request that will hit this endpoint. We're actually going to be creating a couple different lesson requests so that we can sort of test how we're using this endpoint. So we're going to create a new folder within this. Create our new request. And then here we're going to do API/chapter slug lesson slug. And I probably need to restart the server here. Oh, I forgot the course in the URL. That's what I missed. There we go. Now we received this back, so we know we've got this hooked up. Okay. I'm going to save this request. And one thing that we need to do first is to grab the chapter slug and the lesson slug from the route. To do that, we use the event context. Every single endpoint gets passed in this event object. And this object has the request and other details about it that we can grab. And most of the time, we're not actually going to deal with this event directly, but instead, there's a bunch of helper methods that we can use to pass this event into and help us work with it more easily. But for this case, it's pretty straightforward, so we're able to just deal with it directly. So now if I hit send, we see that we're getting this string back, lesson slug, and chapter slug. So that's exactly what we were looking for. We're able to grab the slugs off of the route, just like we were with the page routing earlier. Now we've seen how to create a basic server route. And in the next lesson, we will continue this and finish implementing our lesson endpoint. In this lesson, we will continue on implementing our lesson endpoint. So the next thing that we need to do is to be able to provide the course data from this endpoint. So we're not quite at the point yet where we want to integrate the database. That will come later in this chapter. So for now, we're just going to move the course data from the client side to the server. So we'll come into our composables here, and we'll copy that. And in the server directory, we'll paste that in. So this will let us import it. Course data. And now that we have the course data, why don't we call this course instead? We can actually reuse the logic from our route validation in order to find the correct chapter and the correct lesson based on the slugs. So we're just going to copy this whole thing here. We paste that in, but we don't need params here because we have the chapter slug and the lesson slug directly. And instead of returning abort navigation, we can just throw this error directly. Which will do the same here for the lesson. This is one of those cases where it's really, really convenient for us that the same things that work on the client side also work really well on the server side and in our server routes. So this create error method works just as fine in our Vue components as it does or on our server routes. And we don't have to worry about a different method, a different syntax, a different interface. We can copy and paste code around. And if we wanted to, if this logic got even more complicated, in theory, we could refactor this out into a separate utility method that's used both on the server route here as well as in our route validation. And of course, now that we have found the chapter and the lesson, we need to actually return that object instead of this string here. So we save that, and then coming back over to Hopscotch, we'll send this request again. And you can see that we do not find this because we get an error because we do not have the correct chapter. Now, this is actually great because it tells us that our endpoint is working as it should. One thing that's nice about Hopscotch and other tools like it is that we can create a bunch of different requests, and we can actually add in our own tests. There's a little tab here that lets us write some JavaScript code that will test the request and make some assertions on the request that or the response that we get back. Now, this, of course, does not replace automated testing, unit testing, integration testing, end-to-end testing, but it is a little bit better than manual testing and makes it a little bit easier for us when we do want to just click around and manually tweak some things and check that things are working the way that they should. So we're going to test this just a little bit just to see how this might work. So I'm going to rename this because we're not getting the first lesson. And I can come in here. There's these little snippets that make it really easy. If I change the size, then we can see what they are. A snippet to check the status code. And we want to check that the status code is 404. So we're actually going to do this. And if we save that and send, we can see in our test results that our test is successful, which is great. And we can add in more tests if we wanted to be more precise about what we're doing here. But instead, now that we've tested the error path, let's create a request to test the happy path. So we duplicate this request and we will edit it. And we'll make this one get first lesson. We'll remove that test because it no longer makes sense. And then in order to get the correct slugs, we can actually just cheat a little bit and grab this URL because we're using the exact same URL format. So I'll do /API and then paste in this route that we copied. And if I hit send, you can see that we get back the object that we were expecting. This is the lesson object that we need. And so one thing that we can do here is actually test a property on the response that we get back. So let's do that. And Hopscotch here isn't giving me enough room, so I'm going to decrease the size a bit there. So I'm going to check the title, and I'll just copy this. Hit save, and I'll send that. And if we come over in the bottom here to our test results page, we can see that our test passed with flying colors. Now, we're not quite done with our requests here because we have one issue. If I come in here, let me duplicate this first lesson here. And instead of get, If I change this to a post request, we see that our API responds correctly. But actually, this is not what we want. This endpoint should only respond to GET requests. So one way to do that could be to look at the event, check what method it is, and if it's anything other than a GET method, we could return an error code saying this is not implemented correctly. But of course, Nuxt has got us covered in that arena as well. All that we need to do is add the suffix .get. And this works with any of the HTTP method types. Once we add in .get and we try and send a post request to this endpoint, we get this error that method post is not allowed on this route. This makes it really, really convenient for us to implement the different methods on a single endpoint. So we can have one file that's for get. We could create another file and implement our post. We could do yet another file to implement the patch method. And so in that way, we're able to very easily separate out our methods without adding any extra boilerplate or overhead. And we don't need this file, so I'll just delete that. And there we are. We have seen in this lesson the basics of creating server routes in Nuxt 3. And we've created our first endpoint, the lesson endpoint. In the next lesson, we're going to take a bit of a detour and update our types so that we can make our endpoints more type safe. After that, we'll handle creating the course meta endpoint. In this lesson, we're going to see how to add types to this endpoint. We created types in a previous lesson for the use course composable. And we can take these and instead move them into this endpoint so that we're able to use those types there. But instead of moving them into the endpoint, we want to be able to use them in this composable as well as in our endpoint. So we're going to create a types folder. Inside that folder, we're going to create a course.ts file. And we'll copy in the types that we have here. We need to make sure to export all of these types so that we can import them into the use course composable. So to do that, we'll add in the export keyword. And then we'll import these types back into the composable. We can do that using this tilde, which references the root of our project. So we do the tilde/types/course. But we actually need to select the specific ones. So we grab lesson, chapter, and course. But now that we're importing these, we need to get rid of the local declaration here. So we can just remove that. And now we've got our types in a separate file. One extra thing that we're going to do to make things a little bit easier for ourselves is create a separate lesson type. One that has the lesson as we get it in the course data, and then one with this path added on. To do that, we'll remove this path property from the lesson type, and then we'll create a new lesson type called lesson with path. And here we can use the TypeScript intersection to take the lesson type and then add on some new properties. In this case, we're only adding on a single property. And what this intersection operator does is it basically just combines the two types together. So going back to use course, we'll also import the lesson with path. And we'll update our composable here to use that. Do lesson with path here. This is technically a lesson, just to be a little bit more explicit and clear in what we're doing here. And we'll also add the chapter type to this one here. It's not strictly necessary, but I like to put it in there just to make it a bit more clear what's going on here. One last thing we need to do is we need to go into this chapter type here. So this lessons property can be an array of lessons, but it can also be an array of this lesson with path. So we'll give this some flexibility here because later on when we go to update our endpoint, we'll need this to work in this way. Now that we've updated these lesson types, I also want to get a little bit fancier with some types and add in a utility type for us. I'm going to put this in a global type file because I don't want to have to import this specifically in each file. And in order to do that with TypeScript, we just need to create a file called global.d.ts. And in that file, we have to export here and then also declare this global namespace. And anything inside this global namespace will be global. And so we're defining a maybe type here. And what this does is it lets us take any other type represented by this T here, and that type could be either T, null, or undefined. And this makes it a little bit easier for us to deal with types where we might have the object or it might be null. So now we need to update the lesson endpoint with all of these new types. So we come over here. We need to first import all of our types. We'll paste in this import for our types. We'll put in this statement which turns our course into a course type. It doesn't actually do anything other than give TypeScript a hint that this object that we've imported is actually of the course type. We'll add the return type as a lesson with path. And then our chapter, we could put chapter here, but the problem is that if we come down here, it will show us this error message. And this message says that we have this whole long thing here, which is basically just telling us the chapter type or undefined. Because TypeScript is smart enough to know that what's returned from this find method could be nothing at all if the chapter was not found. So that's where this maybe type comes in handy. This type is maybe a chapter. And so if we hover over this, we can see that this chapter is indeed a maybe chapter. But then down here, we put this guard up. And so TypeScript knows that this either is a chapter or it's undefined at this point. But we're checking for that case with this if block here. So then now when we come down to this section over here, it's no longer undefined as a possibility. We know for sure that it is a chapter. TypeScript is clever enough to infer that through this logic, at this point in our code, this chapter variable must be of the type chapter because we've already handled that undefined case. And so that's why it's really useful to be able to have this maybe type in there. And we'll do the same for the lesson. Now, if we come down to our return, we can no longer simply return this object because it is of the type lesson. And what we want to return is lesson with path. But that's not a problem for us because we can just add on the path right here. We already know the chapter slug and the lesson slug. And now, because we've added on this property, we've satisfied that type, and everything checks out as it should. So if we come back over to Hopscotch, we can test this out. Once I switch over to the get request here, get first lesson, then I'll hit send, and we will get our first lesson, but we'll also have the path added onto it. And so why don't I just quickly add in another test here to make sure that we do get that path. Give myself some room here. And we'll check body.path to be, and then we'll just copy in this path because we know that this one is correct. We hit send, and we'll come over to our test results pane. And we can see that both of our tests now have passed. So at this point now, we have added our first server route to fetch the data for a specific lesson. And we've also added types to that endpoint so that we can make sure that we are fully typed and type safe and leveraging the full benefits of TypeScript. In our next lesson, we will build the endpoint for getting course metadata. In this lesson, we are going to be creating our course metadata endpoint. So we've already got our endpoint for the lesson itself, but in our app, we also have all of this other metadata that we need to access. We need to know the name of the course. We need to know the different chapters and the different lessons that we have in this course in order to render out this navigation on the left side here. So to do that, we'll create a course metadata endpoint. So we'll open up our folder here, and inside of the course folder, we'll add a new file. And since I always forget what exactly this method is called, we'll just copy and paste it in. Also, I'm too lazy to type, but that's okay. So for this endpoint, we're actually going to start it out the same way we did the other endpoint. And we need to grab all of these different types as well as the course data that we'll be using. Now, what we want to do is provide the course title as well as an outline of all of the different lessons. We don't want to provide the lessons with all of that extra data. We could just take this course JSON here and just return that. But of course, that's going to be way too much data, and we have no real need to send all of that over to the browser. To get started, we're first going to create the types that we'll need. Sometimes creating types first feels like a bit of a chore, but actually it's in a way like test-driven development. It forces you to think about your problem and to deconstruct it and break it down into smaller pieces. And once you've created the types that you need, you know that you've thought through the problem clearly, and then implementing it becomes much simpler. So we're first going to start with the types. Our very first type is the course meta. Now this is the type that we're going to return from this method or from this endpoint. As we said before, we know that we want the title and then an outline, which we'll call chapters. And we're going to create a separate type for us without any of the extra things that come with the chapter. And we're going to call that an outline chapter. To create this outline chapter type, we're also going to create an outline base type, similar to what we did with the lesson and lesson with path. So this outline base type will have the title, the slug, and then the number. If we go into our course types here, we can see that our lesson and our chapter both have a title, a slug, and a number. So these are properties that are common to both the lesson and the chapter, and data that we want to be included in our metadata. This is so that we can have the title here as well as the number in here. And of course, we also need the slug so that we can construct that path correctly. So coming back over to our meta endpoint, we have this outline base, and to create the outline chapter and the outline lesson, we use this intersection operator again. So the outline chapter is the outline base, but with this lessons property on it. And the outline lesson is the same, but it also has this path on there. So now we can start to see the structure of the data that we are returning. We're going to have this chapters, which is an array. And all that that array contains is another array of lessons. So now it's time to actually implement this endpoint. And in order to do that, we are going to make use of the reduce function, which is one of my favorite things. And at the end here, we will return the object, the course meta object. So let's quickly go through what this code is doing. So we have our reduce up here, and we've got previous and next, and then this function here that computes that. We're going to start with an empty array. So the types here actually help us to read the code because we can see that this reduce is going to return an array of outline chapters. So that means that this here must be itself an outline chapter, or an array of outline chapters, sorry. If you're not familiar with how reduce works, we first start with this initialized array, which in our case is an empty array. And for each item in this chapters array, we take the previous element and we get the next element. So in our case, we're going to start out with an empty array, which we will say is an outline chapter array. And we'll grab that first chapter. Then we compute all the different lessons from that, and then construct ourselves this outline chapter object. And once we have this outline chapter, we can then stick it onto the end of the array and keep going. Then when we get the next item, we have this array, which now has one chapter in it. And then as we go through the array, we keep adding these chapters to it. So how are we computing these lessons here? Well, here we're just mapping the lessons. And what we're doing is really mapping from a lesson with path type to an outline lesson type. So here is where we're really getting rid of all of the data that we don't need. This implementation could have also been done with two maps. If you are using something like Lodash or another utility library, they also have pick methods, and we could be using something like that. There are a lot of different ways to implement something like this, but this is how I have implemented it here. So now let's go over to Hopscotch to see if we're actually returning the data that we think we are, because that's always the important part. So I'm going to duplicate this request. And then I will move it out of that folder, and we'll edit the name. And then we need to edit the URL that we hit. And now we will run this. So the JSON that we get back is the title of the course, along with the chapters, which is an array. We get the title and the slug and the number for the chapter, as well as all of the lessons. But the lessons only contain the title, slug, number, and path. And as we scroll down, we can see that the structure of this data is, in fact, what we were hoping for. Now, in this particular case, the data is actually not a huge amount. So the difference between what this endpoint returns and what our course data file here is not actually that different. But you can imagine that if our text in the lesson is substantial, that this could actually mean a huge amount of data. Are you going to send over all 50,000, 100,000 words of content in a written course, or are you going to just return the metadata? That can be a pretty significant difference. So if we come over to our test results, we see that it actually failed. And that's because the title is incorrect. So let's update that. The title is not the title of the first lesson anymore, but in this case, the title of the course. So make sure to save that. And now our test runs successfully. In our meta endpoint here, we actually don't need these two types here. As you can tell from the syntax highlighting, they're grayed out. So why don't we just get rid of those before moving on? So now we have two endpoints. We've got the lesson endpoint and the course metadata endpoint. And these should be good enough for us to now transition into putting all of our data into a database and fetching it through our API. In the next lesson, we will look at setting up Prisma with our project so that we can then use a database from Supabase, put all of this course data in there, and use the database instead of a local JSON file. In this lesson, we'll begin to look at data fetching in Nuxt. So we spent the past few lessons building out our server routes and seeing how we can do that with Nuxt with all of the different tools that comes with Nuxt. And now we'll be able to create a couple different composables which will let us access that data really easily. In this lesson, we're going to start with the use lesson composable, which will let us access those lessons. So to begin, we'll create that use lesson file. And then we'll paste our composable code in here. Starting at the top, we will pass in a chapter and lesson slug. And this is what will allow us to grab the correct lesson that we're looking for. We then make a call to use fetch. This is the composable that lets us fetch data. And it's very similar to a fetch command, or the fetch command that you're probably already familiar with and using in other projects. But this fetch command is a little bit more powerful, and we'll return to that in a moment. But in this fetch call, we have our URL, which uses the slug for the chapter and the lesson slug. And then from that, we get our data as well as an error object. So before we return from this composable, we check to see if we have an error. And if we do, we can use this create error method, which we are now familiar with, to throw an error. Otherwise, we can simply return this data ref with the data that we've fetched. We'll use this composable in the lesson page instead of fetching it from the use course composable. So first we have to grab our slugs from the route. And then using those slugs, we can then pass them into the use lesson composable here. Now we need to make sure that we're using this await keyword because in our use lesson composable, we are awaiting this fetch command. And TypeScript is giving me an error now because we've already got this lesson variable defined. But now that we're getting our lesson from this endpoint, we no longer need to compute it from this value here. So we'll just get rid of that. And as you can see, as we click through our lesson here, we get the same outcome. In fact, it looks like nothing has actually changed. So to prove to you that we've actually done something useful here, I'll open up the network tab. And you can see that as we click through, we're making calls to our endpoint with these different request URLs. A different URL per lesson. And the response is the lesson object itself. So this is all pretty straightforward, actually. The use fetch composable is really easy to use. So let's explore a little bit more about this use fetch composable. One thing that's interesting about this composable is that it actually automatically will infer the type of the data that we get back. If I hover over this data, you can see that it knows that this is a lesson with path object, even though we've never specified this anywhere. And that's because it knows based on this route, it can match it up to the endpoint that we just created. When we want to type out the route, we have this autocomplete here because, again, it knows the types of the different routes that we have. And these are the only 3 valid routes that we have in our application. Right? So undo this, come back to our code that works. One interesting thing to note about this use fetch composable is that this URL here, while we have used a string here, you can also pass it a ref of a string, or even a function that returns a string, or a function that returns a ref of a string. And if you use a ref here, whenever the value of that ref changes, useFetch will automatically refetch your data for you. So in theory, we could change this from a string to a ref instead. And then in our lesson slug page here, we could create a computed prop that returns a string and then use that computed in this lesson. But I actually prefer this method here. Instead of passing in a generic string ref, we pass in the slugs, and then the composable itself will calculate what that URL should be. In this way, we don't have to carry around this structure for the URL ourselves. It's encapsulated nicely within this composable here. UseFetch isn't the only way that we can fetch data in our application. In fact, UseFetch is a wrapper around two other functions that are very useful in Nuxt. So we can create an equivalent version of this using the use async data as well as this $fetch. So I'll save this here and refresh. So you can see that as we click around on the side here, our data loads. And so these two implementations are actually functionally equivalent. They do exactly the same thing, but just with a slightly different syntax of doing it. So let's explore how this works. And we'll start with this $fetch. So this $fetch here is very similar to the fetch command that you are used to. It fetches data from a URL. But this command is isomorphic. And that's a really fancy, cool sounding word, but all it means is that it does the same thing on the client and on the server. You'll notice that a lot of the things we talk about in Nuxt actually do this, including this create error method and many other things, which simplifies our lives a lot. But in the case of the fetch command, we can use it on the client side as well as on the server, and it operates in the same way. Except there's one little catch here, and that is that when we're on the server, this $fetch will skip the whole HTTP request thing. Instead, since we're already on the server, this call here is in the same process as our server endpoints. And so this method here just gets directly called, as if it was just another function in our application. So we skip all of that HTTP overhead, which makes it much faster. One other thing that's great and that we've pointed out already is that this $fetch enables this wonderful automatic type inference. Technically, our server-side routes are running on a separate application on the server, and this fetch command is being run on the client side. And so they're actually two separate pieces of code. And so type inference between the two is not always that easy. And so Nuxt does a bit of magic for us and allows us to get this type inference. So we've explained what this fetch part does. But what about this use async data thing? Well, simply put, it lets us use asynchronous data. So any data that will resolve or that we'll have to wait to resolve. And we need to wrap it in this function because Nuxt needs to manage that and make sure that when we do server-side rendering, and then that gets hydrated and then rendered again on the client, that whole process works cleanly. And we want to make sure that we're doing things like deduplicating HTTP calls, so we're not making extra requests that we don't need to, that we're not making a request on the server and then on the client immediately making that same request, but that we're conserving and making things more efficient. So there's a bunch of different stuff going on under the hood here. But this use async data composable is really just a very generic way of handling asynchronous data. And all that we need is some sort of function, any function, as long as it returns a promise. And so that's what this fetch function does here, is it returns a promise, so we are able to use it in our use async data. And so we've shown that these two things here, use fetch and use async data with this fetch command, are functionally equivalent. So why do we have both of these if they do the same thing? Well, if you think about your applications that you're building, the vast majority of the async data that you're working with actually comes in the form of these fetch requests. And so to make that main use case as easy to use as possible, Nuxt combines these two things into the use fetch command. And so instead of using the use async data with the $fetch everywhere, which is a little bit more verbose, a little bit more complicated, we can just use the use fetch composable. Those edge cases where you're not directly using a URL might come from if you're using a library to fetch data, or you have some other functions that you're borrowing from another project or something like that, where you're not providing a URL directly, but instead getting some sort of promise from somewhere else. And so that's when the use async data composable is helpful. All right, so in this lesson, we went through the basics of data fetching in Nuxt, how the use fetch composable works, how use async data works with the $fetch isomorphic fetch. And we've described a little bit and gone through a little bit how these two things differ and when you might want to use one over the other. In the next lesson, we will dive a bit deeper into data fetching, and eventually we'll also add in a composable to fetch that course metadata, which we already created the endpoint for. In this lesson, we're going to look deeper into this data fetching in Nuxt. We're going to look at some important arguments of the use fetch and use async data commands, such as the key, the pick, as well as we will look at the lazy keyword. So if we come over to our API documentation here for use async data, so remember that use fetch actually wraps around use async data. So these have the same or very similar function signatures. You can see that we get a lot of different options here. We can pass in a server, a lazy, some default data, a transform function. We can give it a pick argument, a watch source, as well as this immediate flag. So there's a bunch of different things that we can do to configure how our data is being fetched. But there's one option that's really important as part of this use async data function here is the key. So if you look in the documentation, what this key does is it lets us properly deduplicate the requests. Now, in earlier versions of the Nuxt 3 beta, they did provide a cache along with this, but that had some issues, and so it was actually removed for the stable release of Nuxt. So to be clear, there is no caching except for on that initial page render. However, that's not really much of a problem for us because we can pretty simply create our own cache. So we're going to do that. We're going to use session storage as our cache. And this is because cache invalidation is a very tricky subject and not something I really want to get into in this course. But with session storage, every new session gets completely wiped out. And so that's a pretty good way of clearing out the cache and invalidating it. So we're going to stick with that. So we'll use the use session storage composable, which works in the same way as the use local storage composable that we used previously in this course. We'll have to make sure to import storage serializers as well as import our lesson with path type. And so what we're doing here is, first of all, we're just sticking this URL inside of a string so we can use it in a few different places. And then we're calling the use session storage composable. We're going to use the URL as the key so that whenever we go to a new URL, it will be a different spot in the cache, so that whenever we go back to the same URL, it will just retrieve that value from the cache. We're going to initialize this with null, and then this option we have to pass in because we're giving it a default value of null. The composable does not know automatically what object type we're going to be giving it. So we're just going to tell it we're using an object, and so when we give you an object, serialize it into a string to save in the session storage, and then when we want to get it back out of session storage, it has to take that string and then convert it back into an object. So if we gave it a default like this, then this is an empty object, and we wouldn't need to pass this in. It would automatically know, oh, this is an object, use the object serializer. But in our case, we want to initialize it to null because that simplifies things for us a little bit. And so then we just need to give it this hint. You'll also notice that we've got these funny little brackets here with the type in here. What this is doing is telling the composable that the type that we're using this with is the lesson with path type. And this is important because then the return type that comes back is a removable ref of type lesson with path. And so these angled brackets are basically, you can think of them as type arguments. So if removable ref is a function, this type here is an argument to that function. So that sets up our use of the session storage. And now this lesson variable here is a removable ref. This is the type that the session storage returns back to us. So if this value already exists, then lesson will be the lesson that we've already got. But if we haven't yet fetched from that, then it will be null. So we need to check for this. And so our use fetch and error handling here needs to be updated a little bit. And so what we're doing here now is we first check to see if we've hit the cache. And if we have a cache miss, then we need to fetch that data. So when that happens, we can call this. And here we're giving use fetch a hint that we are actually going to get back this lesson with path, because if we don't, then because we're passing in URL as a variable, TypeScript isn't quite intelligent enough to know and to infer that this URL is of the lesson with path type. And so because we have this variable here, then we just need to give it a little bit of a helping hand here. And then we've got our error handling as before. And then the crucial step here is that once we've fetched that data, we need to put it into the cache. And so updating this lesson value here with the data that we got back from our API will set the value in the cache. Because remember, this is a reactive ref. And so anytime we update this value, it will update what's stored in the session storage. I've also added a little message here so that if we're retrieving it from the cache, we'll just print out a little message so that we know that. And at the very end, we'll return our lesson. All right, so now let's see this working. So if I go to chapter 1, we see that the request comes through. If I go to chapter 2, that request also goes through. But if I go back to chapter 1, we get no request. And in the console, it will say we're getting lesson 1 from the cache. And so if we click around a bunch more, we'll see lesson 3 was already in the cache because that was the first one that we loaded. And there we go. And all of this loading here is actually from this Vimeo script. And that's not really anything that we can cache locally. So that will always take a bit of time to load. Great. And so now we've got a pretty straightforward and basic cache for this endpoint. So I mentioned this key value that we have in this use async data. And you'll notice that over here, we're not actually using the key value anywhere. And this is because by default, useFetch and useAsyncData will automatically generate the key for us based on the URL that we're using and the position of the call within the code. So most of the time, this does a great job for us. But if you do run into issues where data is being inconsistent, or you're suspecting that this deduplication is not happening, then we can pass in our own custom key. We can also use this pick parameter to only bring us the fields of the response object that we actually want to use. So many times, when we're fetching data from an API, the object that's returned has dozens, perhaps even more data fields. And often we only need 1 or 2 of those fields. And so 80% of that data that's coming over the wire is a waste. And we're wasting bandwidth and slowing down our app unnecessarily. Well, with this pick field, we're able to specify that we only want these 2 fields. And when we're on the server side, this means that the amount of data that we are hydrating with our app is much smaller. And it also means that the data object here is much easier to work with because we don't have all of these extra fields that we don't need to pass around everywhere. So if we save this, and now that we've got cached here, I have to create a new session. You can see that we're loading the number, so this renders correctly, and we're loading the title of the lesson, so this renders correctly. But because we're not loading the video ID or anything else, we're not able to get anything more in our lessons. So, not useful for us right now because we need all of the data that we're sending over. But a quick demo of how this pick function works nonetheless. The last option that I wanted to go through of the more important options is this lazy keyword here. Now, normally with this useFetch and useAsyncData, we have to put in this await keyword because we're going to wait, and this promise is only going to resolve once our data comes in. But in some cases, we actually want to continue along our execution here. And instead of waiting for this whole thing to render, we actually would prefer to put in some sort of loading state. Maybe that's a spinner, maybe that's a progress bar, or whatever it might be in your case. If we set lazy to true here, we can get rid of this await keyword. And then we can use this pending property, which will tell us if the data is loaded or not. And then you can use this pending property to switch between your loading state and your normal state. And because this behavior is common enough, we actually get a shorthand for this. Instead of needing to provide that lazy true, we can just use lazy fetch or use lazy async data. But in our case, we want to wait until that data is fully there, and so we'll use it in this regular way here. And so if we come over here, you can see that we've got use async data, but we also have use lazy async data and then use lazy fetch. And so if you want to check those out further, you can find those on the documentation. Now, before we wrap up with this lesson, I do want to point out one more time, just to make sure that it's super clear, is that this use fetch method is a wrapper around use async data. And so all of the options that we can provide to use async data, we can provide to our use fetch command as well. And because use fetch uses that $fetch under the hood, we also get all of those options as well, including method, base URL, and so on. So now we've seen not only the basics of data fetching in Nuxt 3, but also some more advanced ways that we can control how our fetching works, including how we can build a simple but effective cache on top of our data fetching. In the next lesson, we're going to continue on and finish up our data fetching and fetch data from the course meta endpoint. In this lesson, we're going to take this use lesson composable that we have already created, and we're going to turn it into a more generic composable. So right now, this function or this composable lets us fetch data from the lesson endpoint, but we also want to fetch data from our course meta endpoint. And we'd like to be able to do it in a similar way using this session storage caching layer that we've put on top of this data here. So what I'm going to do is actually to copy and paste this into a new file, and then we'll modify it from there. So now we're working in our use fetch with cache.ts file. Now we're going to work through and make this more generic so that we can use it with any endpoint that we want. So the first thing that we need to do is, instead of passing in slugs here like this, we're going to instead pass in the URL straight up. And we'll specify that that is still a string. Then, of course, we can get rid of that line. And now we're going to rename this lesson here. And we're just going to call it cached, because that's a bit more generic term here. Say cache.value, cached, and we'll return the cached value. We'll update our status message to be a bit more generic as well. And then this message here, when we have a cache hit, will also make this more generic. So now we have a pretty generic composable that we can use with any URL, and it will automatically give us this session storage cache layer. But one issue that we have is that we're still using this lesson with path type. Luckily, TypeScript gives us a way to create more reusable functions using generic types. You can think of these sort of like arguments for types. And so that's exactly what these arguments are doing here, or these angle brackets are doing here. This use session storage is a generic composable, and we can pass in any type to it to tell it what type to expect. And we're going to make our function here work exactly the same. So right up here, we're going to put a t, and this means that this is the type of this function. And then instead of lesson with path, we'll replace that with this generic type t. The name here doesn't really matter. You can name it whatever you want, but t is a common variable name. It's used for this generic type. And basically what this lets us do is say that whatever type we want to use this composable with, we just pass it in here. And then we'll take that type, we'll pass it along to this use session storage. And then this use session storage knows that this cached value here is a removable ref of type t, whatever t happens to be, of course. And our entire function continues on in this way, that use fetch of type t. So we're going to get data back that's of type t, and we continue on. Now in this spot here, TypeScript has a little bit of issues with figuring out what's going on here. And so one trick that we can do with TypeScript is to cast from one type to another. So in this instance, TypeScript doesn't know exactly what type data.value is supposed to be. But from looking at this code, I can say that data.value is for sure going to be type t, because it's coming from this use fetch here. And so I'm basically just going to override whatever TypeScript thinks is going on here and tell it that for sure data.value is type t, so therefore we can set it to cache.value. Now this as casting here can get you into some trouble because you are overriding TypeScript. So if you override it incorrectly, then you're basically shooting yourself in the foot and invalidating all of that value that TypeScript is there for in the first place. Okay, so now we have our cached generic composable for fetching data. Now we need to refactor use lesson to use this instead. And it's actually very straightforward. In fact, what we're going to do is remove this import here because we do not need that. And so the first thing that we need to do is basically get rid of all of this. We do need to create our own URL here to pass in. But we can call use fetch with cache and then use the template as an argument there. Now, this is where the generics come in again. Because we have not provided the lesson with path type, TypeScript does not know what this value is, and we get this unknown here. So just like we did with the use session storage method, where we passed in this type t, we're going to do the same thing here. We can pass in the type lesson with path. And now we're able to infer that this fetch here will pass in a lesson with path, and what we're going to get back is a promise that contains a removable ref of type lesson with path. We can also get rid of that import that we don't need, and we're good to go. Now that we have this use fetch with cache composable, we can now use it to fetch data from our course meta endpoint, which we'll do in the next lesson. In this lesson, we're going to take our use course composable that we have been working with throughout this course, and we will refactor it to use the use fetch with cache composable that we just created. We'll also have to refactor a bunch of little things throughout our app so that we can use these new endpoints correctly with the rest of our application. So to get started, we're going to move into our use course file. And we have a lot of stuff going on here because we're taking this course data and then mapping it and adding different path to it, adding types to it. But now that we're having an endpoint that does this for us, we can get rid of most of this. In fact, this use course composable becomes this very simple line here. This is all we need in order to fetch the data from this endpoint. The useFetchWithCache composable handles all of that other stuff for us, except that we need to do one more thing in order to finish this. And that is we need to add the type. And the type here we know is course meta. But we have to import this from somewhere. And currently, this course data type is only defined in this meta endpoint. So what we need to do is pull out these types and move them into our type file that we have created. So we'll grab these and open up our course types file. And then we'll add them in at the bottom here. And then these last ones here, we need to export as well so that we can use them in other parts of the application. Now that we've moved these types out of the endpoint, we now need to import them back in. Now that we've done that, the types in this endpoint should be good to go. And then we just need to import the course meta type from there. And this is all that we need to do to re-implement this use course composable. Now that we have this handy useFetchWithCache composable that does some nifty things for us, as well as our course meta endpoint. The next step is to refactor the rest of our application in order to use these two new endpoints correctly. So we're getting data, but we're getting data in a slightly different way than we were before. So that requires us to make a couple little changes throughout the app. First, we'll go with the use first lesson. And one thing that we need to do is that use course is no longer a synchronous composable. It returns a promise. And so we need to make sure that we await on this. So we'll add this async keyword to the function so that we can add in this await keyword. And then we are getting a ref back now. So we can't destructure immediately off of that. Or at least I prefer to not do that. And now we add in course.value.chapters.lessons, and this works as it should. Now that we've changed the interface of this use first lesson composable, we'll need to update every instance that we use this composable as well. So we'll first go into our course page here where we use the use course composable. And again, we'll add in the await keyword. We'll change this to course. And then where we use chapters and title, we have to update. So we'll put in course.title here. And then course.chapters. And in this component here, we're not using the use first lesson composable yet. But what we want to do is navigate to this first lesson here. So it makes sense that we should, while we're at it, just refactor this part here. Now we've tidied this up nicely. And one thing that's interesting that you'll note is that, yes, we are calling use course in here, and then use first lesson immediately will call use course itself. But because of the caching that we've added in and the caching that use async data provides, we won't ever make multiple calls one after the other to an endpoint. So that's it for the course page. Let's move on to the lesson page. In this one, we have a few things we need to update as well. We need to put an await on this use course here. And in our middleware, we need to put an await on our use course, which requires us to also make this function async. And now that course is a ref, we need to add .value to this. And lastly, down here where we use the course to find the chapter, we'll add the value in there as well. And in the title. Almost missed that one. The last page that we need to refactor is the login page. So let's head over to that one. Same thing as before. I'm going to do await. Replace this with the course. And then we just need to pop in course.title and we're good to go. The one last thing we want to do before we wrap up with the data fetching section of this chapter is to get rid of this course data file in our composables. Now that our data is all provided to us from our endpoint, we don't need to have any of the data shipped to the client. All of that data can stay on the endpoint on the server. Okay, so we're going to restart the dev server to make sure we've got the latest code changes. And because we've got caching based on our session, we'll create a new session. And as we click around, things are appearing to work as they should. We can log out. It says log in to TypeScript with Vue.js 3, which is the title of the course. So that's great. And something looks like it broke here. Why is this link not clickable? I forgot to update the index page here. Okay. So once we do that, then we refresh this, and now this is actually a clickable link. And there we go. We have now refactored our app so that it works correctly with all the endpoints that we created, those two endpoints. So now the data is not shipped with our client bundle, but instead lives on the endpoint. And all of the data that we're accessing, we access through these API endpoints. The next step is now to move that data from our endpoints and move it into a database. So that's what we'll be tackling in the next couple of lessons, setting up our database, setting up Prisma so that we can access our database in a nicely typed way, and then fetching that data from our database in our endpoints instead of using the local files that we've currently been using. In this lesson, we will be setting up our project to use the Supabase database with Prisma as the ORM. So in Supabase, we're going to come over to our database section here. And actually, we need to go into settings at the bottom and then database settings. And we need to reset the database password. So if you were following along with what I was doing earlier when we set up Supabase, we ignored this database password because we weren't using the database at that time. If you've kept that password safe, then you don't need to reset this here, but I am going to reset my password. So we come here, we hit reset database password, and we can specify our own password, or we can get Supabase to generate a secure password for us. So I'll get Supabase to generate that for me. Then I'm going to copy that and just keep it somewhere safe. So for now, I'm just going to paste that into a new file there. And we hit reset and it will reset the password. So we need to reset this password in order to allow Prisma to connect into our database. Now that we've got the password, let's take a little look at Prisma. So if you aren't familiar yet with what Prisma is, basically what it lets us do is write one schema that's used in both our client-side app and in our database. So if you're creating a database with SQL or anything like that that uses a schema, you have to define every single table and the different columns in that table, what their types are, the relationships between those columns, and all of that good stuff. But then in our app, we've also defined TypeScript types so that we have that data when we're developing our JavaScript app. Now, this can become a bit of a pain because we actually have two schemas here. We've got this TypeScript schema for our application, and then the schema in our database. And what Prisma does is instead we define one single Prisma schema, and from that, Prisma generates all of the TypeScript types that we can use in our application, as well as the database schema. So this ensures that everything is kept up to date, everything is all synced together, and that we are able to develop without any issues. And Prisma also handles things like migrations, seeding the database with dummy data or default data that your application needs in order to function. And so we're going to see that later on in the next couple of lessons as we go through setting up Prisma. So now we're going to set up our VS Code environment to make it a little bit easier to develop with Prisma. One of the first things is to install the Prisma extension. So this adds all sorts of syntax highlighting. It adds linting. It does code completion, formatting, very intelligently does formatting, which is very nice. It will autocomplete things to make sure that you're not missing different parts and that your syntax is correct. And so this is actually a very helpful extension. So install that. We're also going to update our workspace settings so that we can use the Prisma formatter that's built in so that we can get all of this formatting. So if we come down here to the formatter section, it tells us how to update this in our VS Code settings. But one interesting thing that we can do is instead of saving this to our user settings, we can save this to the workspace settings so that these settings live in our project. And this is really cool because it lets us work with other people more easily, especially if we are doing formatting like this. We don't want one person to format the code in one way and then have it be reformatted in a completely different way when we use it. So by putting these settings into the workspace instead, they live with the project, and so the formatting will be consistent. Assuming, of course, that everyone is using VS Code. If you do Command, comma, this will open up our settings. And instead of doing the user, we'll just head over to the workspace. and I'm going to search for format, and then I'll enable this format on save here. Now I also want to add in a custom section, and I need to have access to the underlying JSON file. So in order to do that, we can open up that JSON file. So now that we've edited this option here, you'll see that VS Code added this VS Code folder, and inside of that is a settings.json. This JSON has the format on save option. So this will ensure that when we save a file, it will automatically format it. Then we'll need to add another option. And what this one is telling VS Code is that for Prisma files, we're going to set the default formatter to the Prisma formatter. So now when we edit our Prisma schema, it will use the Prisma formatter to tidy everything up for us nicely. So now we're going to set up our database URL environment variable. And this is where we will use that password that we saved just a moment ago. So in order to get that database URL, we'll have to go over to our Supabase settings here. And when we scroll down, we see that we get the connection string here with a bunch of different options depending on how we're connecting to it. But you'll also see that below that is this connection pooling section here. And what connection pooling does is instead of creating a new database connection for every single request that comes in, it will instead create one request or one connection and then reuse that connection over and over and over again. And as your application scales up, you can add more and more connections to that pool. And so this reduces the load on your database and generally improves the speed and performance of your application. Now, for our purposes, we don't really need this, except that we're deploying to Netlify. And Netlify uses Lambda functions, which are serverless. And so with serverless functions, they are spun up and spun down for every single request, which by default would create a new database connection for every single request that comes in, which is not what we want. So we need to use this connection pooling setting in order to force Netlify to reuse that same database connection over and over again. So we'll come down here and we'll copy this string and we'll paste that underneath in here. And right where it says your password, we're going to copy this password into that. But then we also need to append this query string at the end. So this query string tells Supabase that we're going to use PG Bouncer for the connection pooling. And we're going to limit it to a connection of 1. There is more information on how to use Prisma with Supabase. So they have written docs specifically for this. And so if you want to do a little bit more reading on how this works and how we've set this up here, you can go to that. We'll include the link in the description of this lesson. So now we have this URL. We need to add this to our environment. But the key thing here to remember is that we only need this for Netlify when we've deployed. When we're developing locally, we don't need this connection pooling. And in fact, when we try and do migrations and get Prisma to update and work with our database, it actually breaks that functionality. So we want connection pooling when we're deployed on Netlify, but we don't want connection pooling when developing locally. So to do this, we'll go over to Netlify. And now that we're in Netlify, let's go to our site settings and we'll come down to the environment variables section. So what we want to do is, let me first delete this out. So we have our Supabase key and Supabase URL that we have added in previously. But what we can do is add from the UI here instead of the command line interface. We need to give this the name database URL so that Prisma can pick it up properly. And what Netlify lets us do is specify what values are used in what scopes. So if we're developing locally, we can have one value for that environment variable. And then once we've deployed, you can have a different value. So that's exactly what we're going to do here. For production, we're going to paste in this value here that includes our password and the connection pooling string. But then for local development, we need to come over to our database settings here, and we'll just grab this URI here without the connection pooling. We'll need to make sure to copy our password into this one as well. So it is a slightly different URL if you look at it. We're using a different port for the connection pooling versus no connection pooling. And so we want to make sure that we're using the correct one in the correct spot. So we'll paste that into the local development here. If we take a look here, we can see that we have our production value set and our local development value set, but no value set for deploy previews or branch deploys. So I need to go and fix that because we want to be able to preview our deploys as well. There we go. Now it shows that we have a value in all 4 of these places. We've got 2 different values in 4 deploy contexts. So we're good to go. Except we don't have that database URL in our .env file yet. So if I'll come over here, we can see that all we have currently is the Supabase stuff. So one way that we can get this variable in is by copying and pasting since we have it over here. But normally we would not have access to these variables. They would only live in Netlify because we want that single source of truth that's going to be password protected and going to keep our secrets nice and safe. So one way that we can get them is using the Netlify CLI tool. So if we run this netlify env command, you'll see that we also have this get. And so if we do database URL, then we can grab the value that we have set here. And notice that this is missing that connection pooling string because Netlify is going to pull only the local development one, as you would expect. So now we can grab this environment variable here, and we'll add it into our environment variable. And with that, we have done all of the boilerplate setup that we need in order to start working with Prisma, which is what we will tackle in the next lesson. In this lesson, we're going to create the Prisma schema and then use that schema to then generate the database schema and our TypeScript types. So we'll first start by creating a Prisma folder for ourselves here. And we'll put everything in this Prisma folder related to Prisma. So the first thing that we need to create is this schema file. We need to call this schema.prisma. And once we've got that, then we can begin setting up our schema. The first two blocks have nothing to do with our app at all, or nothing to do with the types in our app, but rather are there in order to scaffold and configure our Prisma project. So the blocks are pretty self-explanatory. The first block is describing the database with the URL to that database, and then what type of database it is. In our case, a Postgres database. Then the next section describes what we will be using this Prisma types and schema with. So we need to put this in here because Prisma is actually able to generate clients for many different languages. So we can specify different providers for different languages in here if we wanted to generate clients for multiple languages. We're also able to add in some other options as well and do some configuration, which we don't need to do yet. So if you're on Apple Silicon, you might need to add the binary targets here to the generator so that it generates the correct type of client. And if you're using PNPM like I am, you'll need to specify the output for this client. The reason for this is that because we're doing PNPM with Nuxt 3, we have to include the shamefully hoist option with the installation. And so then the structure of the node modules folder is a little bit different than what Prisma is expecting. So this just gives it another hint so that it ends up in the right spot. So now that we have our basic setup done, we need to add in the different types. In Prisma, they're called models, and they map directly to database tables as well as the TypeScript types. So our first model is the course model. In it, we have the ID, the title, just as we have in here, in our course, we have a title. And so we're adding in this ID so that we can reference this course uniquely. We'll also add in the created at and updated at field. These are really useful because we can easily see when this object was created in the database and the last time it was updated. You'll also notice that we've got some of these attributes here. And so these map to special meta info about the object that our database will use, and Prisma will also use in our TypeScript client. So ID specifies that this field here will be used as the ID property. And this here specifies that by default, we are just going to auto increment this. So we'll start with 1, and then for every course that we add, it'll auto increment it. If you are familiar with SQL or SQL, then these will look familiar to you. So created at, by default, it will use the current time, and then we'll use this special updated at attribute for updated at. Our chapter model is very similar. We've got the ID, we've got created at and updated at, as well as the different fields in our model. And lastly, we'll add in our lesson. Now this one has a few more fields, but the format is the same as the other ones. The only interesting thing to note here is that this string here is optional. So we have this question mark, just like we would see in TypeScript. That question mark lets us denote that this field is optional. So if we come back to our course file here where we define the different types, you can see that this maps pretty closely to what we have got here. The only difference is that with our course, we have chapters, which includes the chapter type. We have lessons, which includes the lesson type. And so what we need to do next is to define the relationships between these different models. So in our SQL database, we would be able to define relationships using foreign keys that reference the ID of other tables in the database. In Prisma, these are called relations, and we can define them by using these attributes. The only difference here in Prisma is that we need to define that attribute on both models, whereas in a database, depending on what the relationship is between the two tables, you may only need to define it in one table. So if we wanted to add the lesson relation to our chapter, we could add this lessons here. At first, it gives us an error, but then when we save it, it will actually auto update. And we didn't see this because it was scrolled below out of view here, but it adds in this chapter and chapter ID field. And so what this is saying is that every lesson has a chapter, and we'll include the chapter ID in the lesson table. Now, up till now, we've been sort of thinking about it as each course has a bunch of chapters and each chapter has a bunch of lessons. But saying that a lesson belongs to a chapter is the opposite way or inverse way of saying that a chapter has many lessons. And so that's exactly what this database is doing, in that each lesson has a field on it that specifies which chapter it belongs to. In our database, there is no field for this lessons here. In addition, this chapter object here does not exist in our database. This is just a Prisma thing. So this lessons here is just for Prisma, and this chapter object here is also just for Prisma. And this relation attribute, what it's doing here is saying that this chapter ID field here references the ID on our chapter, so that we know that this chapter here is actually linked to this ID. And so in that way, in our database, every single lesson object will include a chapter ID that links to a specific chapter that it is a part of. And then when Prisma fetches that data, it can tell which chapter each lesson is a part of. And it can also do some really nice things for us, that instead of requiring us to figure out and put this data together, when we grab a lesson object, we'll also be able to grab the chapter object. And so that's why this is here. This is only a Prisma thing, but it's there because it makes our lives a little bit easier. So although it auto-completed it for us, it's actually a little incorrect because these relations are not optional. So we'll remove those question marks, and now that's correct. And we have only one other relationship that we need to add in, and that is from the course to the chapter. So each chapter contains a bunch of lessons, and each course contains a bunch of chapters. And again, when we save, it auto formats this and adds in this relation here, but it is not optional, so we'll just clean that up. And now our schema is complete. If you want to learn more about schema in Prisma, I highly encourage you to go to their docs. They have a very in-depth and well-written documentation that explains a lot of what's going on and how it relates to TypeScript as well as the underlying database schema. It's also useful to read up on SQL and database schemas in general if you want a deeper understanding here. But since this course is about Nuxt, we won't go into that any more than this lesson. So in our next lesson, we'll be taking this model and initializing our database and then seeding it with the course data that we need in order to use our application. In this lesson, we will be finishing up our setup of the database with Prisma. So we're going to be doing two things. The first is initializing Prisma and our database. And then the second is adding in our seed. And so this seed data will be the course data so that we can actually use our application and we don't have this empty database that's completely useless. So first we're going to install Prisma. Do that with pnpm add-g Prisma, which will install the CLI tool. We'll also want to install the Prisma client itself. Now, what Prisma does is actually pretty interesting. So instead of installing a client that everyone uses, what it actually does is it takes this client that we just installed, and with the CLI tool, it will go through our schema and generate a custom client library. And this library includes all the different types that we have so that it's developed specifically for our application. So if I run Prisma generate, then we can see that it has generated our client to this location here where we asked it to in our schema here. So it's in node modules and then a .prisma folder. So it means you have to scroll all the way to the top here. There we go. It just wasn't scrolling up. That's what I was missing. So here we are in our .prisma/client folder. And so it generated this file for us. And so this isn't actually important for us to understand or to see, but it is interesting to know that when we come in here, it's going to generate this for us, and it's all custom based on our application. So you can see that we've got this chapter with all the different fields from our chapter model, as well as our course model and our lesson model here. Ooh, okay. Yeah, the lesson model here. So it custom generates this for us. And so that's an interesting way of getting around this problem of creating types from our schema. So by doing this, we have access to all of these types. But what this also means is that every time we change this schema, we need to rerun that Prisma generate so we can generate a new client for us to use. Okay, so now we have our Supabase database set up. We've got our Prisma schema set up. We have our Prisma client generated. But if we come over to our Supabase project and we open up this table editor on the side here, you'll see that there are no tables available in this schema. So we haven't actually done anything with our database yet. In order to do that, we run this command, Prisma migrate. And there's a few different commands off of this migrate command. We can use a reset command, we can use a dev command, and a deploy command. So reset will reset your entire database. And this is useful in development if something got messed up with your database or you just want a fresh, clean start. So that's pretty self-explanatory. Then dev is what we want to use in development, and deploy is for when we've deployed our application. So we would run deploy on a continuous integration server where all it's going to do is update the database. What the dev command does is actually a bunch of extra stuff to make sure that our database is going to work properly. So it does things like making sure that the migrations are going to be consistent, that we haven't done anything weird with our Prisma schema that's going to break anything. And it does this with some fancy stuff. It creates a temporary database in the background and runs some things against it. But really, the important part here is that it generates the migration and then runs it, whereas the deploy command only runs the migration. So if I run this command, we'll see it generate that migration. So we have to enter a new name for this. We'll just put init because it's the first one. And it tells us that it's created this migration in migrations folder. So if we come over here to our file explorer, we can see that it has created this migration. So what is a migration? Well, it's a SQL file here. It's a SQL file that contains all of the instructions to run against the database. So you can think of migrations as git commits for your database. It keeps everything in sync. And if you need to reset your database or do any changes to it, it keeps track of that in a really straightforward way. So Prisma generates all of this SQL for us, but you can see that it's creating the chapter table, creating the lesson table, and doing all these different things like linking the lesson to the chapter and all of that kind of stuff here. And so this is important because the migrate dev command will create this migration. And then once you know that this migration works and is correct and isn't going to break anything, then on your continuous integration server, the migrate deploy command will simply run this migration against your production database. Okay, so we've run that. And so if we come over to Supabase now and we refresh, we should see our tables in here. Yes, so we've got all the different tables and they have all of the different columns here that we were expecting. And Prisma created a fourth table for us. And basically what this table does is it keeps track of which migrations that this database has performed already. So this is useful because you might have different databases in development, in staging, in a testing environment, and in production. And you want to be able to know which migrations have been run and which haven't yet. And so this is also useful for resetting. You can do things like rolling back a migration and then reapplying that migration. If something kind of went janky, then this table keeps track of all of that for you. So you don't have to worry about it. And Prisma will handle all of those details. Okay, so now we have our database and it's set up, but it's completely empty. Obviously, this is not helpful to us because we need data in our database if we're going to use it at all. And in our case, we need all of that course data in the database. In other applications, you might have default data in the same way, or you might just want to have some dummy data in this database for development purposes so that when you spin up a new dev environment, you have some data to work with so you can start playing around with the application and developing it. Prisma makes this really easy, and it has a seed feature built into it. So basically, we need to add this field here to our package.json, and then we create a script that will then be run by Prisma. And this script will use the Prisma client to add data to the database. then Prisma will automatically run this seed function or this seed script whenever we reset the database or initialize it or anything where we might need that seed data. So we're going to create our seed file in the Prisma folder. So we'll call it seed.js. And this basic function here, what we're doing is we're going to call this seed function, which is an asynchronous function. We're going to wrap this in a disconnect so that once this is done, or if it errors, we're going to disconnect from Prisma. And then we'll use the Prisma client in this seed function in order to generate all of that data and add it into our database. In order to generate data, you can use a library like Faker.js here, which gives you a whole ton of different objects that you can randomly generate addresses or images or different kinds of animals. You can randomly populate colors, all sorts of things. Basically, anything you can imagine is in here. And this is great for dummy data in tests or to just get something to use in your application so you can, start working with it. In our case, though, we actually have something a lot easier, and that is this course data.json that we actually have been using so far. So we could, as described in the docs here in the Prisma docs for seeding a database, we could go through each individual object type, course, chapter, lessons, and then generate each of them individually. But we can also just pass in a JSON blob, and Prisma will automatically create those nested objects for us. So this is copied straight from the course data.json, but I've had to actually add in a little bit of some changes here. So when we get to the chapters here, instead of putting in this array directly, we have to nest it inside of this create so that Prisma knows to create all of these objects as well. And then when we get down to the lessons, a similar thing, we need to create each of these individual lessons. And we're actually not using this course value, so we can just get rid of that. And so now we have our seed script. If we wanted to, we could get fancier with this and we could combine this with Faker. We could create dummy data for our text, video IDs, URLs, all that kind of stuff. But we already have this dummy data, so we'll use this. The next step is to go into our package.json file. And we need to add a new Prisma field here. And this is what Prisma will look for when creating the seed data. And it will run this command to generate that data. Okay, so now all that we need to do is run that seed file. And if we do Prisma migrate reset, it'll completely reset and then reapply all the migrations to our database. So in this case, it resets it, completely blows away everything we already have, which is nothing. And then we'll seed the database once it's gone through all of the migrations. So we'll say, yes, we want to lose all our data. And it has been successful. Now, if we refresh, we should see all of that data in the database. Okay, so if we look at our chapter table, we can see that we've got all 3 chapters here. We can see that we have this foreign key that links to the course ID. because they're all part of the same course, so they're all going to be 1. We can actually click on this and it will take us to the course, which is TypeScript with Vue. So if we look at this course table, we can see that we only have 1 entry in here because we only have 1 course, but we can add more if we needed to, and we could expand this application to have multiple courses. Similarly, we have all of our lessons in here. The IDs are unique, numbered 1 to 11. We've got the titles and the slugs. We've got the number. So this is the number within that chapter. And then if we come over here to the chapter ID, we can see that they're linked to the different chapters that they're a part of, chapter 1, chapter 2, and chapter 3. So now we have our data, and in the next lessons, we'll be able to rewrite our endpoints so that instead of fetching the data from a local JSON file, we'll actually be fetching the data from this database. In this lesson, we're going to take a look at how we can get data from Prisma. So we've got our database set up and we have data in the database now. So the next step is to actually query that database and get data back from it. So we're going to refactor our lesson endpoint. And so we'll open that up here. And we don't actually need most of this. So we'll get rid of all of that. And I'm going to copy in this code here. So our new endpoint, we import the Prisma client. Then we create a new version of that client. And then inside of our event handler, we're going to grab this chapter slug and lesson slug, which we don't need quite yet, but we will in just a moment. And just to test it out and see that it works, we're going to first find that first lesson. So whichever lesson shows up in the database first, we're going to grab that. So to see these requests, we're going to come back to our hopscotch. Going to open up our mastering Nuxt folder here. Lesson, and come in here and we'll hit send. And our result over here is indeed the first lesson. And you know that it came from our Supabase database because we can see the created at, updated at fields, as well as the chapter ID and this ID here, which are not part of the JSON file. And we're not including the JSON file in here at all either. So that's just one method that we get off of this prisma.lesson object. And there are many, many more. So let's take a look at the documentation for Prisma. And you can see here that we have a lot of different CRUD methods for create, read, update, and delete. If you can see here on the side, you can see we've got a lot of different options for querying our data. We can create a single record or multiple at the same time. We can get by the unique ID. We can get all things in a database table. We can filter based on different queries. We can do all sorts of different things. We can select different subset of fields. We're going to go through a bunch of these different things. So we can update, we can also delete. So that's important to know. So the next thing we're going to look at is this find many. And as you would expect, when we query that, it's just going to return all of the lessons. If we want to be a little bit more specific on which we want, we can use this where clause. And let's say we'll put in chapter, slug, chapter slug. If we capitalize that, then that's what we need to get that type to work correctly. So we save that and we'll run this again. And what we get are actually just 3 lessons. And these 3 lessons are all part of this first chapter. So in this way, we're able to filter which lessons we get, which objects we are returned from this endpoint. And if all we need is a certain subset of that data, we can put on this select clause. In this case, we're going to just grab the slug of each lesson. And there we get back a much, much simpler array of data. If we want to have Prisma not just find the lesson, but also include the chapter object, we can include it in the request. So we can include these nested objects. So if I run this, you can see that for each lesson in the first chapter, it also includes the chapter object nested inside of that. Now, for this particular query, this doesn't really make a lot of sense because we're just repeating this data. But if we change this to find first, for example, then instead of making multiple queries to fetch the lesson and then fetch the chapter, we can do it all in one single request. And our queries here can actually become very complex because we can nest these different clauses within each other. So if we want to include, let's keep this first query here. If we wanted to include the chapter, but we didn't want all this extra data, if all we wanted were the slug and the title of this chapter, we could change this Boolean to an object and put in a select clause that we just saw, set slug to true, and set title to true. Now, when we come over and query this, we'll see that this is a much simpler object in here. So this is just a pretty quick overview of the different kinds of things that Prisma lets us do. It's a pretty simple, straightforward interface on the surface, but it does give you a lot of power and expressivity to sort of change how you want to get your data. So you can nest things, you can do all sorts of stuff here. So it makes it really powerful. And I highly encourage you to check out these docs and see all of the different things that you can do with the Prisma client. In the next lesson, we will be refactoring this lesson endpoint further and finishing it up so that we can return the correct lesson from this endpoint. In this lesson, we're going to finish refactoring this lesson endpoint to fetch the correct lesson from our database. So we've mostly got what we need here for this endpoint, but we don't want to find the first one. We don't want to only look at the chapter slug, and we do not need to include this whole chapter in here. So we're going to get rid of that part. And we're actually going to introduce another field here in the where clause, and that's going to be the slug. So now what this method is doing is finding the first that matches these 2 parameters. The slug of the lesson must match lesson slug, and the slug of the chapter must match chapter slug. If we come over to Hopscotch and run this again, we can see that, in fact, we do get the correct lesson here. But before we had error handling in this endpoint, and so we want to add that back in. to this endpoint now. So we'll add an await here. We'll put in an error handling block here to check if we've actually returned the correct lesson or a lesson at all. And then we'll finally return the lesson at the end of the method. So we'll double check that this endpoint is still working correctly. And then we'll go to our chapter not found, where we query for a chapter slug and lesson slug that do not exist. And we return a status code of 404. So that's perfect. But now that we've updated this endpoint, we also need to update the useLesson composable that fetches from this endpoint. We need to update it because this type here is no longer correct. We're getting this lesson back, but it's no longer the same lesson type. Instead, we need to import the lesson type from Prisma. But one thing that we are missing now is that this endpoint does not return the path that this lesson has. So before we were adding the path on, because we're not saving it in the database, and it is missing from this object. So we need to go and add that on right now. So we'll come back to this lesson slug here, and at the end, we'll add this in. We'll copy over this path, which is not quite the same, but almost the same. And now we're returning the lesson with the path. But this presents an issue to us because this lesson type here that we get back from Prisma does not have a path on it. So we're going to go back into our course types file here where we've defined all of these different types. And we're going to redefine what this lesson with path type is. And to redefine it, we're simply going to import the lesson from Prisma and use that as the base instead. Now, if we go back to our useLesson composable, then we'll actually change it back to what we had before. So we've gone a little bit in a roundabout way here, but we now have the correct types because this lesson with path has the correct lesson type from Prisma, which will stay in sync with our Prisma schema and our database schema. And then we add that additional path field on top of it. So if we come back to our app, we'll give it a refresh to make sure that we're using the latest code. And sure enough, everything works as it should. So in this lesson, we finished refactoring our useLesson endpoint to get data from Supabase through the Prisma client. And in the next lesson, we'll do the same for the course meta endpoint. In this lesson, we're going to now update our course meta endpoint to use Prisma. So we're here in our meta endpoint, and you may at first notice that we have some type errors here. And these type errors are because of this type here that we changed previously. So we updated our lesson with path to actually be based on the Prisma client type, the one that Prisma generates for us. Now, in turn, we use this lesson with path and the lesson in the chapter object, which we then use in the other types that we've got going on here. So if we come back to our endpoint here, we can see that this is messed up because we've sort of started to switch over to Prisma, but we're not fully there yet. So now that we've gotten that out of the way, we actually just need to get rid of everything here because we're going to start from scratch. We don't need any of this. The first thing that we do is import Prisma and create the Prisma client. Then the next thing that we need to do is define our event handler. And so we're going to start with just finding the very first course that is in our database. Now, for us right now, this is the only course that's in our database. But eventually, if we added more and more courses, this would be incorrect because we'd only be able to get that first course. So what we're doing here in this call is we're using the find first method to grab the first object. And then we're going to use this include keyword, and we're going to do it twice. We're going to include all of the chapters, and then within those chapters, we're going to include all of the lessons. And so what this include does is it's sort of like a default select, where we're going to select all of the fields, all of the properties within a particular object. So if we come over to our hopscotch, we make sure that we're in our Mastering Nuxt folder, and then we'll select this get metadata test endpoint that we've got. We can see that when we query this endpoint, we actually get every single thing that's in our database because we're grabbing the course, everything within all of the chapters within that course, and then all of the lessons within those chapters. So we're getting literally everything in our database. So this is not what we want. We want just the outline, just that basic metadata so that we're not giving away course data unnecessarily to people who haven't paid for the course, and we're not giving extra weight, extra data in our request that would make it slower and increase the latency of that request. So in order to select only the fields that we want, we need to use this select keyword. But because the include keyword here is like a default select, we can't combine them together. So our new call becomes this instead. We're going to find the first course, then we're going to select the title and the chapters. Inside of the chapters, we're going to select the title, the slug, the number, and the lessons. And then within the lessons, we're going to select the title, the slug, and the number. So here we're only selecting the outline data that we actually need. So if I make this request again, we can see that we've now stripped down the amount of data that we're sending over the wire. However, we have two issues here with this code, and the first one is pretty obvious in that this code is really hard to understand. It's a big steaming mess of indentation and curly braces everywhere. And the second is that we don't have a good type to represent this course outline. So we need to remedy that. Luckily, Prisma comes with an ability to generate complex types based on how we're actually querying our database. So Prisma will generate the basic default types that we've seen before, like our lesson type, our course type, and so on. But it also comes with some functions and utilities so that we can generate types based on queries. And so what we're going to do is we're going to actually break this out. We're going to sort of normalize this structure. Instead of having it be nested, we're going to pull each of these things into its own object so that we can then combine them together in a way that's much easier to read. But at the same time, we'll be using these Prisma validator types in order to keep these types in sync with our Prisma model so that if we update the schema in the future, these types will automatically update as well. And so we don't run into the same kinds of headaches that we might if we just define all of these types from scratch. So first, I'm just going to get rid of this entirely. And we'll start with our lesson type here. We'll import Prisma. And here you can see we're using the Prisma validator. And we're going to pass it in the generic type prisma.lessonArgs. And then the object that we pass into this validator function is simply this select query that we had before. We're going to select the title, the slug, and the number. And now that we've generated that object, we need to get the type out of it. So we'll use this line. We're going to export the type so that we can use it in other places in our application. And then we'll call this prisma.lessonGetPayload, which is a type utility. And if we pass in this generic type of lesson select, we'll be able to grab this type, pass it into here, and now we've got our lesson outline type. So this part seems a little tricky and a little syntax heavy, and there's lots of boilerplate going on. I'm not going to lie about that. But if you follow this, and you can look at the docs here as well, there's a whole section on advanced type safety. It's actually pretty straightforward if you just want to copy the docs straight off. And that's exactly what I've done here. Before we add in the other types, I do want to just explain my reasoning for exporting from this endpoint file and not from the course file that we have here. So previously we created this whole types folder where we put a bunch of these types in. And the reason that I'm not defining these types in this course file here is that we actually want to reuse this lesson select in the query itself. And so if both the type and the endpoint need this lesson select query here, then I made the decision to put all of that in the endpoint file itself instead of trying to import and export things between different files. This just made more sense to me, and you can feel free to disagree with me on that, but that's how I've done it here. So for our chapters, we'll follow the exact same pattern. In this case, we're going to select those fields, but then we're also going to select and include this lesson select from above. So we're avoiding that nesting, but we're still combining everything into a more sophisticated, more complex query. Finally, we have our course type, which again, we're going to select the title and then include those chapters in there. So now we have all of our types, and we've actually built up the query object that we need to pass in to our Prisma method. So the actual event handler becomes very straightforward for us. We're just going to take this course select, and you can see when we look at the type, it is actually that entire giant ugly JSON blob that we had before, or JavaScript object that we had before. But now we can avoid all of that because we've constructed this up slowly. So now we have our event handler redone in using Prisma. And we've got the right types for it as well. So we need to now update our useCourse composable. The only thing here is that we're no longer using this course meta type that we've defined ourselves, but instead using this generated type. So we'll import that from our server and redo that there. And now, since we don't need that course meta type, we can come into this course types folder or file and delete everything else except for this lesson with path. And now the only type that we've defined ourselves in this file is based off of the generated types from Prisma. Our last and final step is deleting this course data JavaScript file. And with that, every piece of data in our application is now being served from the database. We're not getting anything from the local file system or bundling any JavaScript files that contain that data. We're getting everything from our Supabase database instance. But we do have one issue that we need to address, and that is authentication of our server routes. Our page routes have authentication so that you can only visit them if you've properly logged in. But our server routes do not have that yet, which is a problem because people can technically get that data if they knew the right endpoints. And so that is what we will tackle in the next lesson. In this lesson, we're going to look at how we can use authentication to protect our server routes. So let me go into Hopscotch here, and I've set up this one route here to get a protected lesson, or a lesson that should be protected, rather. If I hit send, then I can get all of the data for this lesson in chapter 2. So the path here, chapter, second lesson, should be protected because we're only giving away that first chapter for free. Yet, if I know the endpoint, I'm able to get that data even if I'm not logged in. And this is because although we have our authentication on the front end, like so, if I try and go into chapter 2, it forces me to log in. But that authentication only exists when rendering pages on the front end. And if we directly go to our back end, to our server routes, that data is not protected. So we're going to fix that. To do that, we will use server middleware. Now, this is different than route middleware because route middleware, we can define which routes it's run on, where server middleware is run on every single server request. Now, at first, this may sound like a big drawback because we cannot define per route what server routes the middleware is being run on. But if you are familiar with Express or other backend server frameworks, this works in very much the same way. We can define middleware and they're run on every single request. So what would we use server middleware for? So there are broadly two main reasons. The first is to inspect the request object. So we can inspect it to see, does this contain this type of header for authentication reasons, which is what we're going to be using it for, and potentially extending that request object, which is also what we're going to be doing. So we can use this for authentication. We can use this for telemetry if you want to record timing data to see how long different endpoints take. You can add that information in using this middleware. You can do logging. You can do error handling, all sorts of things. And if you really want it to be specific to a particular route, you could put that logic inside of the middleware itself and get it to check the route before it executes any logic. But there's another way that we can put it on specific routes, which we will be doing in this lesson. And the reason for that is that we have one endpoint, which is our lesson endpoint here, which we want to protect. But this course metadata endpoint, we actually don't want to protect because we need to be able to access this route even when we're not logged in. And so we'll show how to do that in the rest of this lesson. So all server middleware needs to be put into the server/middleware folder. And then we'll create a user middleware. And Nuxt will automatically find these middleware and register them and then execute them all. Now we'll create a pretty simple middleware for ourselves here. And so what this middleware does is we're going to import from the server module in Supabase. And this little hash here just tells Nuxt that we're trying to import from a specific package, and we're not going to rely on the auto imports. So we're going to get this server Supabase user composable, which does exactly what it sounds like it'll do. It will grab us the Supabase user, but it's designed to be used on the server. So this is the equivalent of the Supabase user composable that we use on the front end. Because of SSR things and different contexts and different data being available on the front end versus the back end, this is split into two different functions. So we've got Supabase user, which is for the front end, and then this server specific one. And so all we're going to do here is every time we make a request, we're going to look for the Supabase user based on the request that's passed in. And then we're going to log out that user. So I'll just restart this to make sure that it picked up the middleware, because sometimes it doesn't always. And then if I go to this first page here, we can see we're just logging out null. And that's because we're not logged in. And so, of course, the user does not exist. If I go to a protected route and then I log in, now we see I am logged in, and now we see that logged out here is my user object. And so this contains all of the user metadata and all the other stuff that comes with that object. And similarly, if I go to our hopscotch here, if I hit send, you'll see that we get null every single time. That's because we're not logged in with hopscotch. So how can we test this? Well, we would test this by using cookies, because Supabase uses cookies to determine or to keep our session alive, our user session. And it uses this cookie to get the user. And so that's what's happening here in this server Supabase user composable. We're passing in the event, and this event is the request that comes in. On that request are all the headers, which include the cookies. And from those cookies, it's able to pull out the user. So if we wanted to test this in Hopscotch, we'd have to pass in cookies along with our request. But unfortunately, because Hopscotch is a browser-based tool, it cannot add in cookies. And so that's a limitation of the browser. And there is an extension version that I believe has the ability to do this. Other tools that are not browser-based will be able to do this. But for right now, for us, this is a limitation. So we won't be testing the logged in route here. In order to do the authentication, instead of logging out the user, which doesn't really help us, we're going to add the user onto our event. And now for every request that comes in, we should be able to inspect that user in our routes and see if this user exists or not. We're also going to create a simple utility function. So we're going to create a folder called utils. Inside of that folder, we'll create a file called protectroute.ts. And this utility, this composable utility, is pretty straightforward. What we're doing here is we're going to look at the context and we're going to check to see if that user exists. And if they don't, we'll throw a 401 error. So now we have these two pieces. We've got our middleware, which adds the user onto every single request. And then we've got this protect route composable, which will, if the user does not exist, will throw an error returning 401. For our specific use case here, this may seem a little over-engineered. You might want to put this use Supabase user composable straight inside of a composable like this. And you may not even need to put all of this logic into a protect route composable. It's only a few lines of code. So you could put this into every single endpoint that you want to protect and have custom logic there. And that totally works. My motivation here is to show you how you could use middleware in combination with a composable in order to do more complex logic and to break down these architecture into something that's a little bit more usable, where you've got a middleware that inspects and does something on every single request. And then you've got a composable that you can put in wherever you want in your endpoint logic that will then use that extra metadata that your middleware put. So now we need to actually use this protect route composable to protect our route. And so we'll go over to our lesson endpoint. And so at the very top of our event handler here, we'll add in the check that uses protect route. We'll also need to import protect route here. And now if we're not on the first chapter, we will run protect route. And this is all that we need now to make sure that the only way you can get to this route is if you are logged in. To show that this is indeed the case, if we run this again, we'll see that we get a 401 returned. This is all because of this chapter here, or this protect route here. But if we go over to get first lesson and we hit send, because it's not protecting the route on the first chapter, we get our data back as we would expect. So we're almost done here with using auth to protect our server routes, but there's one issue with server-side rendering that we have to address. If I click around on the client side here, because the app is already loaded into the browser, things work as they should. But if I refresh the page, which will force it to go back to the server and render it on the server, we get this error that we could not fetch data. And the reason for that is that we need to make sure that we're passing the user session through cookies back and forth properly. By default, the SSR context does not have access to this cookie. So we need to fix that, and that's a pretty simple fix. We go to our use fetch with cache. And then over here, we're going to add in some headers, and the headers will be the cookie. Use request headers. And so what this does is when we're on the server side, we'll actually take the headers from the request that came in, which is causing the render to happen in the first place. We'll grab the cookie from that and then pass that along when we're doing our isometric fetch. So when we fetch on the client side, we have access to these cookies. By default, the browser will always pass these cookies along. But when we're on the server side, Nuxt does that fanciness where it will just call the method directly. But when we do that, that cookie is not present because it's just a method call. And so we need to make sure that Nuxt knows that we want to pass these headers along. So once we've done that, we refresh the page and we get all of our data as we expected. We can click around, it loads, and everything is working as it should. So in this lesson, we saw how we can use server middleware, and we saw how we can protect our routes using authentication. We also looked at a simple pattern for splitting things up and making it easy to do authentication and things like authentication on our server routes. We have a middleware that inspects the request and does something to that request. And then we have a separate composable that then works on that added metadata. In our next lesson, we will take a look at Nitro and H3, two important projects that are used heavily in Nuxt 3 and are important to understand in order to get the most out of Nuxt. So you may have noticed that we imported this H3 event type from H3, and that's because the server that Nuxt uses is Nitro, but Nitro uses H3 as its HTTP server. So if that's a little confusing to you, that's exactly why I've created this next lesson, which will explain all about Nitro and all about H3, how they work, why they exist, and why they're important. In this lesson, we're going to take a look at Nitro and H3. So throughout this course, and also in the docs and other places in your Nuxt app, you may have seen mention of Nitro or H3. It can be a little bit confusing to understand what they are and what they do and how they're useful to us when we're developing Nuxt applications. And so that's what we're going to dive into in this lesson. So in our Nuxt framework, we have Nitro, which is used internally by Nuxt. And in turn, Nitro uses H3 internally. So this gives you a better sense of the structure of what these packages are doing. At a very high level, H3 is responsible for HTTP requests. So when a GET request or a PUT request comes into your application, it is H3 that's responsible for running the server middleware and then the appropriate event handler. Nitro uses H3 internally and layers on a ton of extra functionality, such as file-based routing and bundling and code splitting and all of that goodness. Then in turn, Nuxt uses Nitro to provide the backend for our applications. So we're going to start with H3. So as I said, it's a minimal HTTP framework. And if we come over to our project, we can actually see it being used. So if we come to this lesson slug endpoint, we define our event handler, and this is actually an H3 method where we define the H3 event handler. And the event that comes in that we are responding to is an H3 event. But what Nuxt is doing here is providing this to us and exposing this to us in a very simple way, so we don't have to really understand H3, But if we do understand H3, we can dig deeper into it and get more value out of it. If we look at our protect route server middleware, we'll also see that the type that we've used for this event here is an H3 event. And we've had to import this from the H3 package directly. If you've ever had experience with Express for building Node backends or Koa or other similar frameworks, you'll be quite familiar with how H3 works. The difference is that H3 is designed to be as minimal and as fast and as tree shakeable as possible, so we can build lightweight applications. H3 is also built so that it operates in a very similar way to the composition API. Although on the backend, we're not doing anything with reactivity because the request comes in, and once we run through the code, we return and exit out of that context. So reactivity doesn't really help us there. But the way that you write event handlers in H3 feels very similar to the composition API because of these composable-like utilities. And we haven't used very many of these yet, but in the next chapter, we'll actually see a bunch of these in action. So we have utilities like read body, which lets us read the body of the request, get query, set cookie, which lets us set the cookie on the response. So to give you a bit more context into how H3 works, I'm here on the GitHub page for it. And you can see that here's a basic example of setting up an event handler for this root endpoint. So this API will only return hello world. And so that's all that it really does. You can also see that we are able to create our own routers and do more complex routing. We are lucky in that we don't have to write any of this code because Nitro writes this code for us, which we'll see in just a moment. Here we've got a list of all the different utilities that we have. And so you can see that we can write them in the very, very similar way to writing the composition API. So it feels like we're writing in the composition API. And so we're not having to switch between very different ways of writing code when we're going from the front end to the back end. And so the whole experience is a bit more cohesive because of that. If you want to dig deeper into how these work and their API, you can click over to the JS docs documentation. I often find that I can't find this again, but to get back here, what you need to do is just go to the H3 GitHub repo, scroll down to the utilities section, and then there's this link here. And here we get the entire signature of the different types that it's expecting and a little bit more detail on how to use them. And of course, if you want to dig even further, you can click right into the code and explore that further if you want. So H3 provides us with the HTTP framework. We can listen to requests and then respond to them. We can run middleware on those requests, but that's not nearly enough for us to build the back end of our application. We need to be able to handle SSR, pre-rendering. We need to be able to handle caching. We need to be able to bundle our code so that we can deploy it. And there's many other things that we need to do in order to build a full application. And that's where Nitro comes in. It's a universal JavaScript server that uses H3 to handle HTTP requests. The universal comes because it is able to be run in any environment, whether it's a deployment site like Netlify or Vercel, or on edge workers. And it can also work with any front-end framework. It's not tied specifically to Vue. So Nitro gives us the ability to do SSR, to do static generation. It also builds on top of H3 to give us file-based routing. It will look at our file system and translate that into the routes that H3 then uses. It will auto-configure itself for many different hosting providers so that it will be optimally run when you deploy it. And it's also responsible for building the application. But one cool thing that Nitro does is that it doesn't require any extra code. There's no npm install here. It bundles the server into one bundle of JavaScript that can be run on its own. It's entirely self-contained. It also deals with code splitting and will automatically do that for us based on our routes and any configuration that we have if we're using Vite or Webpack. It also adds on a storage layer so that we can access the file system, access a database, and uses this storage layer, among other things, to implement a caching system so that we can optimize our application's backend. So there's a lot of stuff that Nitro does, a lot of things that we haven't even covered in this course because it goes well beyond the fundamentals of building an application in Nuxt. But there's a lot of power here that you can leverage if you choose to dive into it. So here's the diagram from before, where we've got Nuxt that uses Nitro and Nitro that uses H3. H3 is only there to handle the HTTP requests that come in, and then it runs the appropriate event handler to respond to those HTTP requests. Nitro builds on top of H3 and adds on all of the extra functionality that is required to build a backend. In turn, Nuxt uses Nitro, adds on all sorts of Vue-specific integrations and other functionality so that we get the framework that we know and love. One last thing that I wanted to mention is that Nitro and H3 are these standalone packages that are actually part of a wider project called UnJS. So what the team at Nuxt Labs have done is, instead of building Nuxt 3 as this big monolithic project, they've broken it down into many, many different smaller packages that can be reused elsewhere in other projects. So we've seen that with H3 and with Nitro. You could build simpler applications using H3 if all you needed is a basic HTTP request framework. You could build your own version of Nuxt if you wanted to by taking Nitro and adding some extra functionality on top of it. But in general, UnJS is a collection of different packages like that are just for helping us to make JavaScript applications in general. One package that we haven't looked at is the hookable package. So in Vue, we've got lifecycle hooks that let us create these sort of plugins to extend how Vue works. Nuxt and Nitro also have a hook system so that we can create plugins that hook into the build process or when a page is rendered, and let us create plugins that extend that. That entire hook system is powered by this hookable package. So if you're building your own app, your own tooling, and you want to be able to write plugins for it to extend the behavior, this hookable package makes it very easy and simple to do that. The isometric fetch package that Nuxt is using is also an UnJS package. And if we go to their website, we can see in GitHub that there are a ton of different packages available. So we've seen H3 and Nitro, and we talked about the fetch package. But there's also Consola, which is a console logger. There's also IPX, which is a service for optimizing images. And if you look through here, we can see that there are tons and tons and tons of different packages that we can use. Now, not all of these will be relevant to you building a Nuxt 3 app, but I did think it was important to understand how these packages fit into the broader ecosystem. And perhaps one of these packages here is something that will help you with your application. In this lesson, we saw how Nuxt uses Nitro and H3 internally in order to power a large amount of its functionality. We saw how H3 is a simple HTTP request handler that is used by Nitro, and how Nitro adds on a bunch of extra functionality to create a universal JavaScript server that Nuxt can then use to create a wonderful Vue framework for us. In this chapter, we learned all about server routes in Nuxt. We started out by refactoring our app to move the data into an endpoint, and then from there we move that data all the way into a database. We saw how we can use Prisma to interact with our database in a way that gives us full type support. And then at the end, we took a look at how Nitro powers so much of this amazing Nuxt experience.